Managing 5 acres of crops requires hard work. Managing hundreds of acres of commercial agriculture requires a completely different operational mindset. At this scale, manually adjusting resources across every zone is impossible. Basic, localized wired timers often fail here. They cannot adapt to dynamic environmental changes, like an unexpected rainstorm over the eastern ridge, while the western valley remains bone dry. The stakes rise significantly when you cultivate high-yield, sensitive crops. Orchards like these require hyper-precise environmental control to ensure the root systems receive exact moisture levels. Modern farm operators are moving away from manual spot checking and rigid schedules. They are deploying localized sensors and autonomous valves that operate off the main power grid and receive commands through cloud-based platforms. Scaling a farm effectively requires transitioning your approach. You stop focusing purely on outputting more water and start building a data-driven infrastructure that applies water exactly where and when it generates the highest yield. To understand how this works in practice, we are evaluating the SmartTech AIoT system. This platform promises a suite of core capabilities: 6-in-1 soil sensors, independent solar power modules, and a wireless network capable of spanning a massive 5-kilometer radius. This is an industrial-grade hardware deployment. It relies on IoT gateways, Modbus RTU protocols, and specialized relays. It is not a simple consumer plug-and-play gadget. The primary barrier to entry for operators is understanding how to architect this specific network geometry across their land. The upfront capital expenditure is only part of the equation. To avoid overspending on redundant gateways or under-equipping your most valuable zones, you must map the hardware's complexity directly to your exact acreage and crop value. Deploying sensors across massive acreage requires a reliable communication protocol. The SmartTech system utilizes a LoRa, or long-range, wireless network. The architecture relies on a single master gateway. This central hub can connect to and manage up to 75 individual sensor or valve nodes spread across the property. This specific frequency band achieves a massive 5-kilometer communication radius, bypassing cellular data plans and the expense of trenching fiber optics. The system's limit is 300 nodes. Scaling to maximum capacity requires grouping hardware across multiple overlapping master gateways. By running a LoRa system, you act as your own local telecom provider. This means you must account for your field-specific topography. Hills, dense tree canopies, and buildings will disrupt line of sight and reduce that 5-kilometer range. The network solves the distance problem and eliminates monthly subscription fees, but it transfers that burden directly onto upfront, precise topographical planning. Once the communication network is mapped, we have to look at the physical power infrastructure required at each individual plant zone. These are independent nodes. They are equipped with relays that directly control 4-inch solenoid valves and 3-horsepower water pumps. Each node achieves power autonomy through an attached solar array. On just an 8-hour charge, the battery can provide up to 48 hours of continuous uptime. The immediate operational benefit is massive. You completely eliminate the need for expensive, disruptive trenching of power lines across your soil. The CapEx trade-off is notable. Equipping each zone with its own solar panel, battery, and LoRa node requires a significantly higher initial investment per zone than laying traditional wired PVC piping. There is also a continuous operational trade-off. Agricultural environments produce dust and debris. These panels require routine manual cleaning to maintain that 48-hour charge efficiency. True grid independence trades the unpredictable vulnerability of utility blackouts for a highly predictable schedule of physical maintenance. The physical hardware gathers the environmental data and relays it back to the operator through a customized ThingBoard cloud platform. This dashboard displays readings from the SmartSense pole. The top row tracks precise 6-in-1 soil metrics, immediately isolating localized EC and pH levels. It maps real-time and historical data into line graphs, allowing you to track crop health trends over months. The interface for pump control isolates operational metrics. This layout shows exact battery voltage, water pressure, and tracks the daily flow rates in real time. Integrated data allows for condition-based automation. You can program a 3-horsepower pump to activate automatically, but only when the localized soil moisture drops below a specific, predetermined percentage. The system includes integrated failsafes. If a valve jams or moisture levels flatline, it pushes immediate alerts to your phone via line or telegram. Condition-based automation requires a significant initial period of manual calibration. You have to determine and input the exact ideal parameters for your specific crop before letting the system take over. The cloud platform does not replace agricultural expertise. It requires your expertise up front to prevent the system from executing automated mistakes at scale. We can construct a practical deployment strategy based on the specific operational scale of your land. Tier 1 is the pilot or high-value crop operation. You run a single master gateway to manage anywhere from 1 to 75 distinct zones. This setup is ideal for growers who prioritize hyper-precise EC and pH control over a smaller footprint of high-value yields. The hardware carries a 2-year installation warranty and runs on a free, localized Thai cloud server, making this tier a financially secure entry point for new smart farmers. Tier 2 represents commercial expansion, pushing the system to manage between 76 and 150 independent zones. At this node density, the technical requirement shifts. You must link a second master gateway to handle the increased hardware load and potential line-of-sight challenges. The operational value unlocked at Tier 2 is delegation. The platform supports unlimited user access, allowing the owner to distribute monitoring and mobile app controls across multiple on-site farm managers. Tier 3 is the industrial enterprise level, maxing out between 151 and 300 nodes across 3 gateways. Operators graduate past mobile notifications, relying instead on the platform's API to export continuous data directly into Excel for vast resource tracking. Implementing this level of infrastructure requires a specific operational mindset. Do not invest in this AIoT system merely to turn a pump on with a smartphone. Invest so your farm's environmental data makes the watering decisions for you, freeing you to focus entirely on yield.